Have you ever looked back at some brilliant code you wrote, maybe just 6 months ago, and thought, wow, this is a tangled mess? Well, today, we're cracking open the playbook from Google to figure out how they write software that doesn't just work today, it actually lasts for decades. Our guide for this is the book Software Engineering at Google. And this isn't just some academic theory. It's a collection of hard-won lessons from building some of the biggest and longest-running software systems on the entire planet. This is wisdom forged in the fires of massive scale. So let's get into it. You know that feeling, right? It's something every single developer has felt. You ship a cool new feature. Everything is working perfectly. Fast forward 6 months, and trying to make even a tiny change feels like you're defusing a bomb in the dark. So what's going wrong here? According to Google, the whole answer lies in one crucial distinction. It's not about the code you're writing right now, in this moment. It's about building an engineered system that is designed to adapt and evolve over time. And let me tell you, that shift in perspective changes absolutely everything. This brings us right to the first major idea from the book, which is that there are really two fundamental mindsets a developer can have when they sit down to work. So on one side, you have programming. This is the immediate act of writing code to solve a problem that's right in front of you. But on the other side, you've got software engineering, and that's a whole different discipline. It's about considering the entire lifespan of that code, how it's going to be maintained, how it's going to be scaled, how it's going to be worked on by huge teams over many, many years. And this, right here, is the heart of the book's entire argument. Software engineering is really just programming plus the dimension of time. You see, time is the ultimate test. It introduces new dependencies, new user requirements, new technologies, and your original code has to be able to handle all of it. So if time is the big challenge, what's the first major obstacle that it throws your way? Well, you might be surprised to learn that it's the very people who use your software. This is something called Hyrum's law, and you should think of it as being as fundamental to software as gravity is to physics. It's unavoidable. It basically says, look, it doesn't matter how well you document your APIs. If a user can see any behavior in your system, even when you didn't intend, someone somewhere will start to depend on it. Let me give you a real-world example of how this bites you. Take a hash table. We all know its main feature is that it stores things in an unordered way. But what if, just by chance, it happens to return items alphabetically? Well, a user is going to notice that and build a feature that relies on that alphabetical order. The second you fix or optimize your hash table and that accidental order disappears, bam, you've just broken their whole workflow. This is what makes long-term maintenance so incredibly tricky. Okay, so if Hyrum's law tells us that basically any change is risky, how in the world do you manage that risk, especially at scale? The answer is pretty simple in concept. You have to find the problems before they find your users. This chart perfectly illustrates a principle they call shifting left. As you move from left to right, from the design phase all the way to production, the cost to fix a bug doesn't just go up a little bit, it goes up exponentially. It just explodes. Think about it this way. Catching a problem when you're just designing it, that might just be a quick conversation, it's basically free. But fixing that exact same flaw after it's live and affecting millions of users, that can cost a fortune in engineering time, support calls, and worst of all, lost trust. That's why things like automated tests and code reviews aren't just best practices. They're literally fundamental economic strategies. This whole idea brings us to one of Google's most famous and maybe most effective internal policies for making sure this shift left thinking actually happens. It's called the Beyoncé Rule. And yeah, it's memorable, it's a little bit funny, but the actual policy behind it is deadly serious. And it's an incredibly powerful tool for allowing teams to make changes safely. So here's the formal policy. Imagine you're on a core infrastructure team and you're rolling out a change that's going to touch thousands of different projects. It's literally impossible to know every single dependency out there. So the Beyoncé Rule puts the responsibility on the product teams. It says, if a certain behavior is critical for your product to work, then it's your job to protect it with an automated test. This is the social contract that lets Google's core systems evolve without everything constantly breaking. Okay, but even the best technical policies on Earth are pretty much useless if you don't have the right human element in place. And that brings us to the topic of culture. Let's just think about a simple question for a second. In any complex system, mistakes are not just possible, they are absolutely inevitable. So what happens when your organization's knee-jerk reaction is to find someone to blame? Well, the outcome is totally predictable, and it's incredibly toxic. First, people start hiding their mistakes. Then, teams stop taking any risks. And innovation, which is all about experimentation and the possibility of failure, it just grinds to a complete halt. And your best engineers? They're going to leave. They'll go find a place where they feel psychologically safe enough to actually do their best work. The alternative is to build a blameless culture. Now, this is not about avoiding accountability. It's about shifting the focus. When something goes wrong, the question isn't, who did this? The question is, why did our system allow this to happen? Every single failure is treated like a free lesson in how to make the entire organization stronger and more resilient. So after all this, after exploring time and scale and culture, we really come all the way back to that central question of mindset. It really all comes down to this. Are you just writing code to solve today's problem, or are you truly engineering a system that's built to last for the next decade? Because embracing the reality of Hyrum's law, shifting left to catch problems early, and building a blameless culture, that is the difference. That is the real work of an engineer. That's our look at it for today. If you want to keep scaling your skills, make sure you subscribe to Lazy Reader. Thanks for tuning in.